So in the previous videos, I have shown you the rules of inference like the modus ponens, the modus tollens, hypothetical syllogism, etc. So we have used those laws to analyze the validity of a certain argument of statement. So what is indeed a valid argument? So as a review, it is a sequence of statements where each statement is either a premise or follows from the previous statements called the premises by the rules of inference. So the last statement is called as the conclusion. So a valid argument takes this form. We have a set of premises and the last statement as the conclusion. Okay, so we can say that a certain argument is valid if the truth of the premise implies the truth of the conclusion. Now let us have this example. So from a single proposition, P and P implies Q, show that Q is a conclusion. So we can rewrite it as P and P implies Q, therefore Q, wherein this is the premise and Q is the conclusion. Okay, so we have this written down. This is the premise on the step 1. We have P and P implies Q as the premise, and we can simplify this using the simplification rule. And the simplification rule states that P and Q, therefore P, or P and Q, therefore Q. Because if this is true, then it means that the P is true or the true is also true. Okay, so we have listed here down the P, which is the first, the premise, and we have the P implies Q, which is the second, the term in the premise. Okay, and by the modus ponens, using the 2 and 3, we have the Q. Okay, if you remember the modus ponens, we have P and P implies Q, therefore Q. Okay, so by modus ponens, we have arrived to Q as the conclusion. Okay, so let's have another example. So suppose we have this hypothesis. It is not sunny this afternoon and it is colder than yesterday. So we will go swimming only if it is sunny. And if we do not go swimming, then we will take a canoe trip. And if we take a canoe trip, then we will be home by sunset. And we want to arrive at this conclusion that we will be home by sunset given the premises provided. Okay, so the first thing is, how can we prove the validity of this argument? So what we can do is to convert it into its argument form, wherein we are going to identify the individual propositions and replace them with propositional variables. So suppose P is, it is sunny this afternoon. So this is, will then be not P. So, and then we have, it is colder than yesterday. So it is colder than yesterday. So this is Q. So we have P, not P, and Q. Okay. And then we have, we will go swimming only if it is sunny. Okay. So we will go swimming can be R. So this is R. And then, or this is R. And it is sunny. So that is actually just the P. So we have R implies P. And if we do not go swimming, so that is simply the negation of, R. So we have the not R. And then we will take a canoe trip. So that is the propositional variable S. We will take a canoe trip. So we have not R implies S. So if we take a canoe trip, so that is S and then we will be home by sunset. So that is the conclusion, which is D. Okay, so we have arrived to, this is simply S implies D. Okay, so now we have listed down our premises. So we have the not P and Q. R implies P, not R implies S, and S implies T. And we have the conclusion D. So using these premises, we are going to use the rules of inference in order to arrive at this conclusion T. So you can start with any of the premise as long as you arrive to the conclusion. So let us start with first. The premise, we have the P implies not P and Q. And that is the first premise. And from this premise one, we can apply simplification. If you remember simplification, we have the P and Q. Therefore, P or P and Q. Therefore, Q. So this is the simplification. Okay, so we have the not P. And then we can use another premise. We have the R implies P. And what we can do is apply modus tollens to steps 2 and 3. So do you remember modus tollens? It has this form, not Q, and P implies Q, therefore not P. Okay, and it has this form. So you can see that we have the not P and we have the P. So therefore, we arrive to not R. Okay, and we can use another premise. We have the not R implies S, and we can apply modus ponens to steps 4 and 5. So do you remember the modus ponens? So this is this down first, the modus tollens. And we have the P, and P implies Q. Therefore, Q. So this is the modus ponens. Okay, and we can you can see that there is the not R here. So therefore, we have S. Okay, and then we can use another premise. We have the S implies T, and we can apply a modus ponens against to this. So we have, as you can see here, a pattern. So S and S implies T, therefore T. And we have successfully arrived to this conclusion. So remember that we can also use truth table to show that these premises will arrive to this conclusion. However, we need like 32 rows for this because we have 5 na propositional na variables, right? So to compute that, we have to raise to 5 because each of the variable has either true or false na values, and raise to 5, so we need 32. And this is a very tedious na process. So let us have another example. We have this hypothesis. If you send me an email, then I will finish my program. And if you do not send me an email, then I will go to sleep early. And if I go to sleep early, then I will wake up refreshed. So hypothesis or the premises, okay? And using inference rules, we must arrive to this conclusion. If I do not finish my program, then I will wake up refreshed. So what we can do is to convert this into an argument form. So this is an argument, okay? And we must convert this into its argument form, okay? So we can do that by identifying each of the individual propositions and representing it with a propositional variable. So let us do it one by one. So we have, you sent me an email, so that can be P. Okay, and where else? So we have, I will finish my program. So that can be Q. So you can represent it as P implies Q. And if you do not send me an email, so this is P, Q. And if you do not send me an email, that is simply a negation of P. Okay, and then I will go to sleep early. So that can be R. So we have not P implies R. And if I go to sleep early, then I will wake up refreshed. So we can represent, I wake up refreshed as S. So I go to sleep early is simply R, and I will wake up refreshed is S. Therefore, we have R implies S. So if I don't finish my program, so that is simply a negation of Q, and I will wake up refreshed. So that is S. So we have the not Q implies S. So we have this as premises, and we have this as our conclusion. And we will now use the rules of inference in order for us to arrive to not Q implies S. So we have this list of premises as well as the conclusion. Okay, so you can start with any of the premises, and so long as you arrive to this conclusion. Now let us start with the first premise. So we have the P implies Q. Now, we can also use law of, or the rules of logic, right? So like, for example, we can convert this into its contrapositive. And we know that P implies Q is logically equivalent to not Q implies not P, which is its contrapositive. Okay, so then we can also rewrite use another premise, not P implies R. And we can use hypothetical syllogism using the 2 and 3. Do you remember what a hypothetical syllogism is? You can see a transitivity, right? So we have, you can see here, the not P. So we have not Q implies not P, and not P implies R. So therefore, we can say that not Q, oops. We can say then that not Q implies R. Okay, so we have this on number 4. And then we can use another premise. The R implies S. Okay, and we can use another hypothetical syllogism for 4 and 5. So we can see here, and then we have the similar R. So we have the not Q implies R and R implies S. So by hypothetical syllogism or the transitivity, we can say that the not Q implies S. And we have successfully arrived to the conclusion. And now